So hi, I'm Michael Dawson, and today I'm going to talk to you about diagnostic tooling so you can be ready for when things go wrong in production, because we always know that things are going to go wrong. And I also like to call it, why you should be interested in what the Node.js community working group, diagnostic working group is working on, because we're always looking to get more people involved and to come and help out in this very important topic. So a little bit about myself before I get started. I'm IBM's community lead for Node.js. That means I get to be involved in a lot of the community activities, working groups, teams, currently a member of the technical steering committee. But it also means that I get to work with a lot of great groups within IBM on the things that we're working on. You heard Beth give you an introduction on some work we're doing with modules. So if you're interested in things like running Node in the cloud or figuring out how to pick your modules, feel free to come and talk to us at the booth or reach out to any of us to understand what IBM's doing both in the community and inside. This talk was put together as a co-talk between myself and Mike Kaufman. Mike is a principal architect at Microsoft, and he's actually the chair of the working group, so it would have been great to have the two of us up here. But unfortunately, he hates long plane rides and does have a small child, so he couldn't make it with us today. So what am I going to talk to you about today? Well, I'm going to start out by talking about fail fast. This is something that has been actually talked about for quite a while. And sometimes people kind of look to it to say, well, then why should I be interested in diagnostics? So I hope to dispel that concept. I'll then give you an introduction to the working group and what we've been working on over the last little while. I'll talk about some of the key initiatives. And then finally, I'm going to go into some scenarios and demos to show some of the tools that are out there and hopefully give you a little bit of insight as to where you might reach or what kind of tools you might reach for if you run into one of these scenarios when you're sort of working on your own applications or you have something go wrong in production. So first of all, I just wanted to touch on fail fast. So, this is actually a concept that's been talked by some of the leaders in our community, software community, for quite a while. This is a link from Martin Fowler. And really the concept is that, if something goes wrong, we don't want to try to code around that and to continue to run. We really want to just stop running, recover, and keep going. And what I've heard on occasion is people kind of look at that and say, well, why do I need to worry about diagnostics? If I'm just going to kill my process, restart, and keep going, I don't really need to worry about what actually caused that problem because I recovered and I just kept on moving. But really, that's not actually, at least in my opinion, a good way to look at it. If you look at some of the key metrics that mature organizations use to measure their applications in production, so things like mean time to failure, mean time to discovery of problems, or mean time to recovery, all these things require that you understand what's going on when those failures happen. And if you don't actually pay attention, you're going to have things like an accumulation of problems. So if you just, maybe you have a problem which is very intermittent, it happens once every 1,000 requests, 100,000 requests, and that's not so bad, but you ignore that. You make some more code changes, now you're going to have a second one, and over time those can accumulate. So if you don't actually figure out what those intermittent problems are, you're going to get more and more of them until they actually really are going to be like a constant problem. They're also an early warning of something that's going wrong. So it may be that it's an edge case that on your application that's only being used infrequently, but as use scales up, maybe you're going to have even more usage, and it's going to actually become very, very important. They're always customer impacting, so even if they're infrequent, you don't want to have that even infrequent bad user experience, so you want to avoid that. And then there's also cases like performance and resource usage where, even though you don't fail, you're costing yourself money or you're providing a poor experience for your end user. So you really do need to understand what's going on, be able to monitor what's going on, and if you have hard failures, investigate and figure out what's causing them so that you can make sure you provide the best experience possible. So we had the community had a diagnostic summit earlier this year in Ottawa, and we dove into what are some of the key scenarios that you might run into or think about in terms of diagnostics. And so this is the list we came up with. There's things like hard failures where you have a memory leak, you run out of memory, your process dies. You have a crash because you have a native module that's doing something with the memory that causes a segmentation fault. You can have things like performance. So maybe you have consistent or sort of periodic poor performance, or maybe your application works great at a certain scale, but when you try and take it to the next level, it just falls off the cliff. You can have things like excessive resource usage. So even if your application is actually performing well in the view of the customer, maybe you're using a lot of CPU or a lot of memory, and that's ending up costing you, a fair amount of memory because, for example, you're deployed in the cloud, you're paying per memory, and you're paying more than you have to. And then finally, the last scenario is that you just actually want to keep track and understand what's going on in your application. How quickly am I serving my requests? Basically the sort of heartbeat of what's going on so that you know if you should be doing something different or if everything's going well. In terms of those scenarios, the toolkit that we can reach for, or commonly reach for, include a number of different things. So starting out with things like logging and tracing. A primitive example of logging is adding that printf in your console. Obviously, we don't want to use things like that in production, so there's more sophisticated approaches to get log messages, trace messages out. And they help you with sort of the execution of, what is my application doing. We can use things like profilers. Profilers help you understand what your application is doing in terms of like where's the CPU being used and stuff like that. And then finally, the next thing in our toolkit is a snapshot of the execution state. So there's different forms of this. So basically, if our application's running, we can take a picture of what's going on, and from that picture, we can try and figure out maybe later on what's happening. So we can do things like core dump is one that's supported by operating systems, gives you a picture of all of the memory that your application is using, and from that you can investigate, what's the layout of the objects, what was my application doing. In managed languages like Node, where we have a garbage collector, another common snapshot of the state is that of the heap. So you can look at all the memory that's being managed for you by the garbage collector and figure out what's going on from that. And then finally, sort of easier starting point is often a first failure data capture type output, where it's a small, concise, often human readable snapshot of the state, and I'll talk a bit more about that later on in some of the examples. And then finally, in the toolkit, there's often APIs that are provided, and those are things where you can either hook events or register to be told about additional information. So ways where you can actually plug in and get a tighter integration with the runtime itself so that you can get better diagnostic information. And these pieces of the toolkit are all things that the Diagnostic Working Group has been working on. So the Diagnostics Working Group is a working group within the Node.js project. And you can go, we do all of our work in a very open, transparent manner, very GitHub focused. So if you want to see what's going on, the meetings are there. There's an issue for every meeting that takes place. You can see the minutes. You can see, we try and document everything that's going on. So if you have any interest and want to read more, you can easily get up to speed through that. The mission of this is the mission of the Diagnostic Working Group, and really the goal is to provide the best, not necessarily provide the tools themselves, but make sure that Node provides the resources needed so that you can have really good diagnostic tools in terms of tools that build on the APIs and data that the Node runtime provides, so that when we're in production, we can actually support our Node.js applications really well. And this is important in particular to us at IBM, of course, because we offer support for Node applications, and so we want the tools to be able to support things when they go wrong. These are the current team members, and thanks to everybody who's involved in helping already. The one thing I do want to say is don't be put off by the number of people there. This is actually a very broad and deep area, so even though there's a good number of people on the list, we're actually still spread quite thin in terms of covering all the things that we want to do. So if you have an interest, there's definitely work that we could really use your help for. Some of the key initiatives that we're working on, and I'll talk about some of these on the following slide, so I won't go into as much detail on all of them, but we're working on things like documentation and best practices. Brian just talked to us about documentation, how important that is, and that's certainly a view we share, so I'll talk more about that. And then we have efforts around tooling and data sources. James mentioned yesterday the concept of support tiers, and again, I'll talk a bit more about that on the following slide. In the state of the Node.js, he also talked about trace events. So again, that's something where we want to provide more information in terms of being able to track the execution floor. I have a few slides on that. Node report is an example of that first failure data capture, so I'll talk about that as well. Some other things I won't go into as much in detail, though, is we have a group which is focused on postmortem with promises. Promises provides a bit of a different model, And some of the specification actually makes it challenging to do some of the things that we could do traditionally with regular exceptions and so forth. So actually there's a whole group of people just looking at that particular problem, trying to figure out how to make progress on that. Node.js and the JS API. So Node is actually a really good tool. We talked about one of the tools being a core dump. And core dumps actually, it's a snapshot of all the memory of your application, which has got a lot of information in it. But if you ever tried to work with one, it actually can be very difficult. If you want to say, let me look at the state of a particular object in the heap, for example, you have to know all the byte offsets and stuff like that, whereas Node is a tool that lets you open up the core dump and lets you actually just say, I want to say bang JS object, and it understands the structure of the data that's there, and it will print that object out there. So Node is a great tool to help you introspect those core dumps. And there's work on a JavaScript API on top of that, which I hope will actually make it much more accessible to JavaScript developers so that you can help to write diagnostic tooling and help progress this front without having to dive down into the C++ type coding. And then finally, diagnostic channel is the concept of having a channel where you can hook in for more information. So there's some work on that front. And finally, on the API front, one of the key things we're working on is async hooks, and I'll talk a little bit more about that, so I won't go into it now. But if you sort of want to follow what's going on, there's a set of strategic initiatives on the README, so that's a good place to get started in terms of saying, okay, what are the key things that are going on? So diving into some of these, starting with the documented best practices. So really, as again, I think Brian was saying, we can have the best diagnostic tools ever, but if nobody knows where to find them, they're not actually that much good. So documentation is one of our key focuses because we want to make sure that people know what tools exist. We want to know how to use them. We have some existing work in the working group here. I have a couple links to some pull requests in terms of building those diagnostic how-tos. But there's actually still a large amount of work on this front to be done. So if you have an interest in diagnostics and you're a great writer, we'd really appreciate your help because this is an area where we have a lot of work to do, both to kind of curate the best practices, because unfortunately things tend to change as well, and I'll talk a little bit about that. Actually, in this context, in that one of the how-tos that we were developing, when I went to put together the demo for this talk, I actually found that some of the steps didn't work anymore. So one of the things we need to do is to actually put these together, but then also to make sure that they continue to work and sort of have the safety net that makes sure that that's the case. James mentioned the support tiers. And this sort of fits back with what I just said, is that it's great to have a set of tools, and to actually, once we get to the point where we have them well documented and a good set of best practices, we really need to know that they continue to work, and we haven't always achieved that. So this is our current effort where we have set up a set of support tiers, and our goal is to move tools up the list in the sort of tier level, so that we have a strong focus when we make our releases, when we're landing fixes on our diagnostic tools, and we know how the changes affect those, and that we know that we're not regressing them. So we have tiers 1, 2, 3, 4. 1 is like we just will never break this because it's so important. 2 is we don't want to break this in LTS releases. 3 is we should be testing this in our CIs. And 4 is well, we know the tool exists, but actually, it's not critical enough for us to do something in the project to make sure it keeps working. Although, we obviously want everything to keep working. This is the current list. One of the things, again, we could really use help with is adding tests to our infrastructure, or just adding tests that we can run in our infrastructure to help move these tools up the tiers. Because that's one of the key things. If we're going to say that a tool is at tier 2 or tier 1, we better have testing that backs up that we know it's working when we make those releases and so forth. On the API front, the key thing we've been working on over the last few years is async hooks. We all know that Node is very asynchronous oriented, and one of the challenges can be following flow across the different asynchronous calls. But that's something that's really important in terms of understanding what your application is doing, figuring out if it's doing the right thing. Two key things are really, I've got listed there. Async context formalization. This came out of our sort of desire to figure out, did we have the right API in the async hooks API, which we've developed and tested out over the last little while. And so Mike Kaufman, the co-presenter, he's actually put a fair amount of work into this. And this gives us a sort of language that we can use to reason about asynchronous behavior. And the goal is to use that to be able to validate what we have in async hooks. The interesting thing is that it may actually point that maybe we still need to tweak the APIs or change it a little bit, which is kind of a validation that it was interesting and useful thing to do. We also think that it's not just a Node thing. Asynchronous and sort of talking and reasoning about it applies to JavaScript in general, so it's something that may actually get pushed back to TC39 as a concept. Async hooks itself has actually been very successful in that it provides the API that you can see there. You can register hooks to be sort of informed before and after asynchronous events happen. And there's already a number of good tools that are using this API to provide some really interesting information. So BubbleProf, which is a tool developed by NearForm, provides a nice visualization of what's going on based on what it can get out of the asynchronous hooks. And Doctrine published this good blog post on actually how they used async hooks to follow HTTP request, basically execution path through their application using async hooks as well. So if you're interested in how to get started, those are two good areas to look at. So you're saying, okay, this is interesting, but how does this help me? What I'm going to do is go back to a few of the scenarios and try and illustrate a few of those to show how the work that we're doing in the working group relates to those actual scenarios, and why the work we're doing will actually help you when you're in those scenarios yourself. The first scenario I'm going to look at is node report. So I talked about a first failure data capture, and this is something that a number of different languages have had, and my personal experience have found that sometimes a little bit of information can actually help you resolve a problem very quickly, and Node Report aims to provide that kind of information. Currently, it's a module which you can npm install. It does have native dependencies, so it requires the compiler and so forth. That's one of the reasons we're working to actually pull it into core so that it's just there all the time. We've had a few comments on the help repo when we've said, hey, well, here's something you can go use. It's like, oh, now I have to go install this, but I'm in production. So we're working to actually have it just be there as part of the core tools. It provides an easy human-readable dump. You can actually run it today by using the -r to load the module at startup, and you can set parameters like which events you want a node report to be generated on, and if you want to be able to trigger them by sending signals and so forth, you can set that in the environment. I've got some links there if you want to read a little bit further. So to demo this, I put together a first scenario, which is like, hey, I've got an application and I don't have enough memory. This is fairly artificial, of course. It's just some code that basically just uses more and more memory. And then I'm actually going to run it. You see the command line below, where I'm going to set node report and say, well, I want it to be generated when there's a fatal error. And I'm going to artificially limit my old space buys to 128 megabytes. Now, this may be artificial, but when you deploy to the cloud, often you do have some sort of memory limit, and it may not be something that you set on yourself. So having a little bit of limited memory, and actually maybe less than you expect, is not as unreasonable as you thought. So here's the demo. I'm actually going to start up that same application, and it's going, I'm setting my, through the environment, the node report options. I'm going to start the application, and you're going to see that we get an out-of-memory error. Now, this is what I get on the console, so I get a little bit of information. But now I'm going to open up the node report that was generated, and you're going to see that we have actually a lot more information. The first thing that's really interesting there is that actually you can see the command line where I've set the memory limit. So, that's something where if, somebody's reporting it out of memory, and you can immediately see the command line that limits memory, maybe that's something that's contributing. It also includes a section with very detailed memory information. So from here, I can see the GC behavior. It's telling me I can see clearly I was out of memory in my heap. So again, in this particular scenario, very relevant. Lots of other information, like information on the libuv handles, my environment variables. Things that have been really useful in other contexts are things like my ulimits. Maybe somebody set my ulimits so that I can actually only use a small amount of memory. Again, this is all information that often lets you say, there's some sort of environmental constraint that's causing the problem, and actually very quickly resolve that. So this is the place that I would usually go first, is to get one or more node reports to figure out, okay, do I have enough information to kind of figure out what's going on pretty easily. The second scenario is, what is my application doing? I actually want to know what the execution flow, because something isn't working as expected. What is my execution flow? You can turn on basic tracing. So tracing is part of our toolkit, sort of figure out what's going on. As I mentioned, you can do like a printf. Now, tracing is really the much more sophisticated form of that, where we use tools and technology to provide much more efficient implementation. So things like ring buffers and other techniques so that we can capture data very efficiently and actually then dump it out either onto the local file or remotely if you're running in the cloud, for example. So there's some basic tracing you can turn on, so things like trace GC, trace op, but those will output to the console. Trace events provides a more unified view of trace information. You can get it. We inherited and implemented the trace engine from V8 into Node itself. And what that gives you is a unified view where you can get events both from V8 and from Node and see them in a unified view. One of the advantages is that you get the data all across and you can get a nice time series so you can see what's going on. And because we use the same trace engine as V8, we can actually also use the trace event viewer from Chrome, which is quite nice on that front. If you want, I can't go into this section in detail because it's actually, there's a whole talk's worth of information on that. But if you want to actually watch that talk, one of my colleagues, Jarish, presented on that topic, and you can go watch that at the link that I provide there. In this case, I provided a pretty simple example. I've got the command line that shows turning on trace events, so I can turn on trace event categories, the different V8 ones. I then open a file synchronously, and I can see that my trace file actually generates a lot of data. What's interesting there is that it shows you how long things took, and you can turn on different events and stuff like that. And then finally, as I mentioned, because we're sharing the trace tool with V8, we can actually use the Chrome tool to visualize those. If you see the little bars that are sort of green and aqua, those are the open and close functions that are being called on and off. I want to move on next to the last scenario, which is performance. So I've got an application, but it's not performing as well as I expected. Flame graphs are one of the key tools that you can use in that case. And what a flame graph does is it visualizes profile data. So we'll use standard profile tools like Perf, which is a Linux profiling tool that actually understands Node.js. So there's some integration there so we can understand both what's happening at the C level and the JavaScript layer. And the flame graph visualizes that data so that we can easily figure out where we're spending more time than other. It is part of our best practices, and so there's a couple links there. And again, this is a key example where we need to have that tiering and that testing because we did have some problems with flame graphs and profiling along the way that I'll talk about. So this is the demo. I'm going to start out by starting a Node application, and it's a Fibonacci program with Perf. Basically, let that run. It then will basically say I want to take a snapshot of the perf data so far, and then it uses a tool to generate a flame graph from that data. It's all fairly straightforward in terms of the kind of tools the kind of steps that you need to take. And sort of, once you can do this and find the sort of how-to, it should be pretty easy to do itself. What's interesting is that in this case, we can actually then see from our profile where we're spending our time. And what the way you figure out where you're spending the most time is where you have a large bar, and that bar at the top is where the function that you're spending a lot of your time in. In this case, it was I found this quite interesting because I said, okay, what am I going to run that will actually generate some CPU usage that I can profile? So I generate Fibonacci. I did the flame graph, and if you look at the top entry on the flame graph, it tells me that it's bignumber.js is where I'm spending all of my time. And when I open up and it tells me the line number, so I went in and I looked at the code. And what it turned out is that it was using toString. So I'm generating a Fibonacci sequence, yet toString is where I'm spending all of my time. And that really was confusing until I actually, I could look at the line numbers and where it was telling me I was spending my time. And it turns out that as part of the Fibonacci generation, it actually had an event that it supported where it would generate an event telling you what the next Fibonacci number was. So even though my application didn't care about all the intermediate values, there was this event being generated, and to generate the event, they'd convert the number to a string. and emit that event, which I never even listened to. So the flame graph very quickly let me drill down to where the application was spending time. And in my case, I didn't even need that part of the application at all. So I could, if I'd written the Fibonacci implementation, I could actually have removed that code or changed it so that it wouldn't have fired all those events all that time. And so I thought it was a really good example where actually running the flame graph on a very simple example very quickly showed me where I was spending time in my application that I just didn't need to because it had nothing to do with what I was trying to output. Interesting thing also about the flame graphs is in 8.x, we broke them. When we moved up to a newer version of V8, it changed the pipeline so that instead of using the older method where it would automatically JIT all of your code directly to native code, it used an interpreter. And so it would interpret your JavaScript until it decided it was hot, and then when it was hot, it would convert it to the C native code. The problem is that the profiling tools and that generated the data no longer could understand what was going on when it was being interpreted. It would basically report, and you can see that in here, that instead of actually telling me that I'm running in Fibonacci and giving me the line number, it's just telling me I'm in an interpreted function within V8. So we lost the ability to actually see what's going on in number of stack frames. And that's one of the things that Matthias from the Diagnostic Working Group then figured this out, went back, made some commits to V8 itself to help fix this, and also shows why we need that tier testing to make sure that as we move forward, we're not going to break these key tools that we think people need to use in production. So to recap, I gave you a little bit of an introduction to the diagnostic scenarios and the toolbox you can reach to deal with those. Hopefully introduced you to the Diagnostic Working Group and got you interested in some of that work so that you'll come out and work with us. And showed you some examples of when you get into those scenarios, how the tools that we're working on will help you. So I want to end up with finally, it'd be great if you wanted to come out and help out. We've got a number of initiatives, so you can find an initiative. It's a very open and welcoming group. You can reach out to anybody who's listed as one of the champions on those initiatives, or you can reach out to myself if you just want to figure out how to get involved in the diagnostic front. So, reach out, make contact, and contribute. And really, like we say across the whole Node.js project, please, come join us in making the future of Node.js. Thank you very much.